Imagine sailing across a flat, endless horizon, only to realize your vessel is descending not down the slope of a passing wave, but into a permanent, miles-wide depression carved into the very fabric of the ocean itself. You cannot see it with the naked eye, but the instruments do not lie. Beneath your hull, the ocean surface is literally dipping downward, forming a massive physical valley in the open water. This is not an optical illusion. This is the Puerto Rico Trench, a colossal jagged scar slicing through the seafloor for over 1,000 kilometers. At its deepest point, the Milwaukee Deep, the abyss plunges to a staggering depth of more than 8,300 meters. A cold, silent chasm that could swallow Mount Everest and still leave miles of water pressing down above its peak. But the true mystery of this place is not its bone-crushing depth. It is something far more unnatural. Deep beneath this 5-mile deep trough lies a subcrustal mass so dense, an ancient slab of the Earth's crust forced down into the mantle, that it exerts an invisible, terrifying gravitational pull on the water above. It has created the most negative gravity anomaly on Earth, measuring a shocking -380 milligauss. This massive deficit of mass acts like a planetary magnet, pulling the lithosphere downward with a relentless, active force. The pull is so intense that the ocean's surface actually sags, creating a physical depression that satellite altimetry can map from space. For centuries, sailors crossing these waters reported strange navigational challenges, their compasses behaving erratically and their instruments giving false readings, completely unaware that the physical force of gravity was warping around them, pulling them subtly but dangerously off course. How does a mariner navigate an ocean when the very laws of physics begin to bend? The Puerto Rico Trench is a place of dynamic disequilibrium, a violent boundary where the North American plate slides past and descends under the Caribbean plate. It is a slow-motion car crash of continents, moving at the speed of fingernail growth, yet packing enough accumulated energy to unleash earthquakes exceeding magnitude 8.0 and trigger catastrophic tsunamis that could devastate the entire Caribbean basin in a matter of minutes. This is the threshold of the deep Atlantic, a silent witness to the raw, unyielding power of a planet that is still very much alive and restless. As we look out across the restless surface of the Atlantic, we must realize that this ocean is not just a body of water. It is a vast, breathing, interconnected engine of supreme unpredictability. Stretching over 106 million square kilometers, it is the second largest ocean on our planet. A massive aquatic highway that binds the Americas to the west, with Europe and Africa to the east. It spans the entire globe, running from the frozen, ice-locked wastes of the Arctic Ocean in the north, all the way to the wild, wind-swept Southern Ocean in the south. cross it is to navigate a gauntlet of climates, transitioning from serene, sun-drenched tropical seas to violent, mid-latitude storm belts, where the sky and the water merge into a single chaotic nightmare. To understand the courage of those early explorers, we must look to the ocean's very name, derived from the Greek Sea of Atlas, the Titan who carried the weight of the heavens on his shoulders. For centuries, the Phoenicians were among the first to test these waters, pushing their fragile wooden vessels beyond the safe, land-hugged corridors of the Mediterranean. They sailed by the stars, reading the cold coastal currents and the unpredictable shifts of the Atlantic breeze, constantly fearing that the next horizon would be their last. Later, the Norsemen, navigating with sunstones and raw intuition, crossed the icy subpolar gyre, braving freezing spray and towering icebergs to reach Greenland and the shores of North America. Each of these voyages was a leap into a dark, endless void. There were no rescue fleets, no satellite coordinates, and no guarantees of return. This heavy weight of history lies buried beneath the surface, waiting in the silence. It is a silence that feels ancient, preserving the quiet echoes of Earth's earliest history far below the reach of wind and storms. Yet today, millions of people sail across these same waters in steel-hulled giants, scrolling past these hidden triumphs, treating the ocean as mere empty space on a map. But we are different. We know that the true story of our planet is written in the places we cannot see. We know that the deep preserves secrets that humanity is only beginning to comprehend. What lies beneath these restless waters? How does life survive in an ocean shaped by constant motion, freezing cold, and immense pressure? And why has the Atlantic become both a vital lifeline for human civilization and a quiet, dark graveyard for countless ships and souls throughout history? This is an ocean that never rests. It is a world of extreme contrasts, where the same currents that regulate our global climate also fuel the most destructive storms ever recorded by humanity. It is a domain where distance magnifies danger and where nature, in its most majestic and terrifying forms, sets the absolute rules. We are going to dive deep beneath the waves, past the dangerous storms of the surface, into the absolute blackness of the abyss. We will trace the titanic, volcanic mountain spine of the Mid-Atlantic Ridge, walk the silent deserts of the abyssal plains, and stand beside roaring, superheated hydrothermal vents, where alien ecosystems thrive without a single ray of sunlight. We will uncover the stories of legendary shipwrecks buried under shifting sands and examine the terrifying modern anomalies that still leave the world's greatest scientists completely baffled. The journey ahead is long, dark, and filled with wonders that defy imagination. If you are ready for this epic journey, drop a comment telling me where in the world you are watching from. Hit the like button, subscribe to Unseen Nations, and turn on notifications so you never miss more of our upcoming videos. For thousands of years, the human mind treated the Atlantic Ocean not as a path, but as an absolute, terrifying wall. To the ancient empires of the Mediterranean, the world ended at a narrow, rocky gateway. The Greeks called it the Pillars of Hercules, the sheer cliffs of Gibraltar and Abila rising like twin cold sentinels against the infinite. Beyond those stone gates lay the outer ocean, a realm of perpetual fog, boiling seas, and gargantuan monsters that waited to swallow any ship foolish enough to sail past the horizon. The mapmakers of old drew terrifying creatures in the empty spaces of their charts, writing a warning that echoed through generations. Here be dragons. It was a psychological barrier as much as a physical one, a boundary that defined the limits of human courage. Can you imagine the absolute terror of standing on those rocky cliffs, looking out at a vast, gray, empty expanse, believing that if you sailed just a few miles west, you would fall off the edge of the living world? But there were those who refused to be bound by fear. Long before the rise of Rome, the Phoenicians, the master mariners of antiquity, began to slip quietly past the Pillars of Hercules under the cover of night. They were not driven by glory, but by survival and trade. They sailed their sturdy, cedar-planked vessels out into the open Atlantic, navigating by the position of the North Star and the subtle, cold tug of coastal currents. They pushed north along the rugged coast of Europe to trade for tin in Cornwall, and south along the windswept shores of West Africa. Yet, they kept their discoveries a closely guarded secret. If a rival vessel attempted to follow a Phoenician ship into the Atlantic, the captain would purposely run his own vessel aground, sacrificing his ship and crew to keep the outer world hidden from competitors. Why do you think they went to such extreme lengths to guard the secrets of the sea? Was it purely for wealth, or did they realize that the Atlantic held a power that could change the fate of empires? As centuries bled into one another, the northern reaches of the Atlantic became the stage for an even more daring saga of survival. The Norsemen, sailing from the cold, mist-shrouded fjords of Scandinavia, did not have compasses, charts, or astronomical tables. They relied on raw, unyielding intuition and the legendary sunstone, a calcite crystal that could polarize light, allowing them to locate the sun even through thick, freezing fog. They braved the subpolar gyre, a system of swirling, icy currents that brought them face to face with towering white icebergs and monstrous, crushing waves. They pushed farther and farther west, establishing settlements in Iceland, Greenland, and eventually the the shores of Newfoundland in North America. They proved that the Atlantic was not an infinite void, but a vast basin dotted with hidden lands. But their triumphs were eventually swallowed by time, preserved only in oral sagas that the rest of the world dismissed as myth. It was not until the 15th century that the true scale of the Atlantic began to be systematically mapped, triggering the age of exploration. European navigators realized that to conquer this ocean, they could not fight its forces. They had to understand them. This led to the development of the caravel, a nimble vessel equipped with lateen sails that allowed ships to sail at an angle against the wind. But the greatest discovery of this era was not a piece of technology, but an invisible map of the sky and sea. Explorers mapped the great planetary wind systems, like the trade winds and the westerlies, and the massive currents like the Gulf Stream. They learned that to go west, they had to sail south first, catching the equatorial winds, and to return home, they had to ride the westerlies in a giant clockwise loop across the ocean. This was the Volta du Mar, the turn of the sea, a navigational masterpiece that transformed the Atlantic from a terrifying barrier into a highway of global trade. Yet every mile of progress was bought with human lives. The seabed became littered with the skeletons of wooden ships that miscalculated the winds, ran aground on unmapped shoals, or were crushed by sudden, violent Atlantic storms. Off the volcanic margins of Lanzarote, researchers still search for the remnants of ancient trade fleets, swallowed by shifting sands and geothermal currents. These waters preserve a silent record of human ambition, where the gold of the New World and the lives of thousands of mariners lie buried together in the dark. It makes you wonder, is the ocean truly just a blank space between continents? Or is it a vast, watery archive holding the secrets of our species' greatest triumphs and tragedies? As we stand on the shoulders of these ancient mariners, we must ask ourselves a difficult question. If you lived in an era when the ocean was an unmapped mystery, would you have been one of the brave souls to step aboard a wooden ship and sail into the unknown? Or would you have stayed safely on the shore? Share your thoughts in the comments below. If you are captivated by these stories, take a moment to like this video, share it with someone who loves history, and subscribe to Unseen Nations so we can keep bringing these forgotten frontiers to light. The surface of the Atlantic has been mapped, but as we are about to discover, the true danger of this ocean lies not in its width, but in its depth. To navigate the surface of the Atlantic is to accept a chilling truth. Stability is a fragile, fleeting illusion. Above the quiet, dark depths, the surface is a chaotic battlefield of raw planetary energy where warm tropical winds collide with freezing polar fronts and where a serene sea can transform into a white-capped nightmare in a matter of hours. Serving as the cradle of the world's most powerful hurricanes and the birthplace of massive storms, the Atlantic does not merely experience weather, it creates it. For centuries, sailors have known that the moment they lose sight of the coast, they place their lives in the hands of an unpredictable giant that has never learned the concept of mercy. For generations, the greatest fear of any deep-sea mariner was a phenomenon that science insisted was physically impossible: the rogue wave. According to old mathematical models, the ocean surface was predictable. Oceanographers calculated that even in the most violent storms, a wave exceeding 15 meters was a statistical anomaly that should only occur once every 10,000 years. Sailors who spoke of towering, solid walls of water rising 90 feet out of a dark, relatively calm sea were dismissed. Their terrifying accounts were chalked up to exhaustion, panic, or grog-fueled exaggerations. But the ocean does not obey human mathematics. In March of 1861, off the rugged, storm-beaten west coast of Ireland, the keepers of the Eagle Island Lighthouse experienced the impossible. The lighthouse stood on a sheer cliff 40 meters above the boiling sea, with the stone tower reaching another 26 meters into the sky. Yet at midday, a colossal rogue wave emerged from the gray horizon. The massive wall of water surmounted the 40-meter precipice, surged upward, and struck the lantern room at the top of the tower. It shattered 23 panes of reinforced glass, extinguished the light, and washed the lamps down the stairs. To cause such destruction, a mountain of water had to rise over 66 meters, more than 210 feet, above sea level. The keepers were left huddled in the freezing dark, listening to the heavy weight of the ocean battering their stone sanctuary, realizing that the boundary between the sea and the sky had completely vanished. If a stone tower anchored to a cliff can be breached, what hope does a steel ship have? In December of 1978, the German cargo carrier Ms. München set sail from Bremerhaven. At over 260 meters long, she was one of the largest and most technologically advanced merchant vessels of her era. Engineered with double hulls, the München was widely considered to be practically unsinkable. But on the night of December 12th, amid a monstrous Force 11 storm, the ship tapped out a series of weak, frantic mayday calls before falling permanently silent. A massive international search operation was launched, involving nearly 100 ships and planes. The colossal vessel had vanished. No oil slick, no hull, and no survivors were ever found. The only clue recovered was a single unused starboard lifeboat. It had been secured 20 meters above the waterline. When investigators examined it, they were horrified. It had not been launched by the crew. It had been torn clean from its steel mounting pins, twisted by a force so immense it defied engineering limits. The most accepted theory is that the München was confronted by a rogue wave of terrifying proportions, a wall of water nearly 100 feet tall. It is believed the wave collapsed directly onto her bow, destroying all electrical systems and plunging her into immediate, helpless darkness before dragging her to the bottom of the sea. But the open ocean is not the only place where the Atlantic hides its teeth. Near the coast lies the most notorious shipwreck zone on Earth, the graveyard of the Atlantic. Off the Outer Banks of North Carolina, the warm waters of the Gulf Stream collide head-on with the cold Labrador Current. When these two colossal marine systems clash, they drop their massive loads of sand and shells at the point of impact. The result is diamond shoals, a series of treacherous, constantly shifting underwater sandbars that stretch for over 14 miles into the ocean. During a storm or under a thick blanket of fog, they become an invisible trap. Over 5,000 ships have been grounded and battered to death by the waves on these shallow bars since record-keeping began. This natural trap has also been stained by human conflict. During World War II, Diamond Shoals became the stage for a brutal, silent slaughter known as the Battle of Torpedo Junction. German U-boats would sit quietly offshore in the deep water, waiting in the dark. As American merchant ships sailed parallel to the coast, their silhouettes were starkly outlined against the bright lights of the cities onshore. One by one, the submarines fired, sinking over 100 ships in a matter of months, turning the graveyard of the Atlantic into a fiery, oil-slicked war zone. Of all the thousands of tragedies buried beneath these shifting sands, none captures the fragile nature of human ambition quite like the sinking of the steamship Central America in September of 1857. The wooden-hulled sidewheeler was carrying over 400 passengers and 10 tons of gold prospected during the California Gold Rush. But off the coast of the Carolinas, she ran directly into a devastating Category 2 hurricane. The violent winds shredded her sails, and a failing seal in the paddle shaft allowed water to pour into the engine room. The boilers died, the pumps failed, and the ship settled heavily into the rising water. As the passengers realized the vessel was doomed, a surreal scene unfolded in the dark cabins. Men who had spent years risking their lives to amass fortunes suddenly realized their gold was entirely worthless. In the face of the yawning, watery grave, they ripped open their heavy leather treasure belts. They scattered thousands of dollars in glittering gold coins and dust across the cabin floors, leaving full purses untouched on sofas. One miner empty-handedly dashed $20,000 in gold dust across the wooden floorboards, shouting for anyone to take it who still cared. But nobody reached out a hand. In those final, terrifying hours, the gold was treated as nothing more than heavy, useless dross. They realized that the ocean was the only true master, and its price was paid not in gold, but in blood. If you were on that doomed ship, watching the dark water rise, what would you have done with a belt full of gold? Would you have held on to it until the very last second, desperately hoping for a miracle? Or would you have cast it aside, realizing its uselessness in the eyes of the deep? If this story has moved you, please like this video, share it with someone who appreciates the hidden histories of our world, and make sure you are subscribed to Unseen Nations as we prepare to descend past the volatile surface into the absolute, crushing blackness of the abyss. Imagine leaving the sun-drenched surface of the ocean behind, letting your body slip quietly beneath the waves, and embarking on a journey where every foot of descent is a step away from the world you know. At first, the water is warm, bright, and vibrant, filled with the shifting patterns of solar rays dancing through the shallows. But as you sink deeper, a subtle, chilling transformation begins. The colors of the world start to die. Red is the first to go. By the time you reach a depth of just 10 meters, the warm crimson hues are filtered out by the water column, leaving only blues, greens, and grays. By 30 meters, orange vanishes. By 50, yellow is gone. The ocean is slowly stripping away the spectrum of light, wrapping you in a cold, monochromatic shroud of deep blue-green. At 200 meters, you cross an invisible planetary boundary. You have left the sunlight zone and entered the mesopelagic, famously known as the twilight zone. Here the sun is no longer a bright, warming sphere. It is a dim, ghostly glow, a fading memory of the world above. The light is so weak that photosynthesis is impossible, meaning no plants can grow, and the water temperature drops rapidly, plunging toward the freezing point. In this perpetual gloom, you are surrounded by a silent, drifting army of creatures that spend their entire lives in a state of suspended animation, waiting for the cover of night to migrate upward to feed. As you descend further, the pressure begins to manifest as a physical, crushing presence. Hydrostatic pressure is a relentless, mathematically precise force. For every 10 meters you sink, the weight of the water above you increases by 1 full atmosphere. Roughly 14.7 pounds of pressure pressing down on every square inch of your body. By the time you reach 1,000 meters, you enter the bathypelagic zone, the midnight zone. The light is now gone. The darkness is absolute, complete, and terrifyingly vast. The temperature hovers just above freezing, and the pressure has reached a staggering 1,500 pounds per square inch. If you were to step outside a deep-sea submersible at this depth without a pressurized suit, the weight of the ocean would instantly collapse your lungs, liquefy your tissues, and crush your bones into dust. Yet, the deep Atlantic is not a static, silent basin of dead water. It is a world of colossal, invisible movement. Deep beneath the surface, between Greenland and Iceland, lies one of the most astonishing natural wonders on Earth: the Denmark Strait Cataract. Most people believe the world's largest waterfall is Angel Falls in Venezuela, or perhaps Niagara Falls. But they are looking in the wrong place. The largest waterfall on our planet is completely submerged, hidden beneath the waves of the North Atlantic. It is created by a profound difference in water density. The freezing, highly saline waters flowing south from the Arctic Ocean are incredibly dense and heavy. When this cold polar current collides with the warmer, less dense waters of the Irminger Sea, the heavy Arctic water has nowhere to go but down. It plunges over a massive undersea ridge, cascading 3,500 meters, nearly 11,500 feet, down into the deep Atlantic basin. This invisible underwater cataract carries a volume of water equal to more than 300 times the flow of the Amazon River, crashing down in a silent, thunderous surge that reshapes the deep-sea currents of the entire Northern Hemisphere. It is a waterfall of epic proportions, yet it occurs in complete pitch-black silence, entirely unseen by human eyes. How does life navigate an environment where sight is a useless sensory organ and where the dark is a permanent, unchanging reality? In this absolute blackness, the animals of the deep Atlantic have had to bypass the traditional rules of evolution. Consider the bizarre spookfish, a small, spectral vertebrate that drifts through the midwaters of the deep. While almost all vertebrates on Earth rely on lenses to focus light onto their retinas, the spookfish has developed an anatomical masterpiece. It possesses a pair of eyes split into two linked parts, one pointing upward to watch for the silhouettes of prey against the faint, residual glow from the surface, and the other pointing down into the black abyss. But it is the downward-pointing eye that defies scientific explanation. Instead of a lens, it uses a highly complex mirror composed of stacks of tiny, reflective crystalline plates. This mirror acts like a satellite dish, gathering and focusing the incredibly faint bioluminescent light emitted by deep-sea organisms, allowing the spookfish to see in a world where lenses are entirely useless. It is the only vertebrate known to science that uses mirrors instead of lenses to navigate the dark. A startling reminder that in the deep Atlantic, nature will always find a way to overcome the impossible. look into these deep black waters is to look back in time into a realm that has remained unchanged for millions of years. It is a place of absolute isolation, where the distance from the human world is measured not in miles of land, but in miles of crushing vertical water. It makes you realize how fragile our existence truly is, clinging to a thin, sunlit crust on the surface of a planet that is mostly cold, dark, and indifferent. In the absolute stillness of the deep Atlantic, far below the reach of wind, waves, and sun, life does not merely survive. It endures with a quiet, breathtaking resilience. To enter this realm is to understand that the rules of the surface world no longer apply. There are no plants here, no green fields, and no warm sunbeams to ignite the cycle of life. Instead, the entire ecosystem is built upon a continuous, silent rain of organic debris falling from the sunlit waters miles above. Oceanographers call it marine snow. It consists of tiny decaying fragments of plankton, microscopic shells, and organic matter drifting slowly downward through the water column, looking like a gentle, perpetual blizzard in the beam of a submersible's headlights. For the residents of the abyss, this cold, drifting snow is the ultimate lifeline, a sparse, floating harvest that sustains a complex web of life in a world of absolute scarcity. Imagine living in a place where food is so rare that every meal is a miracle, and where every movement must be calculated to save the tiniest fraction of energy. Because of this permanent famine, deep-sea creatures have evolved bodies that seem to belong to another planet. Many possess transparent skins, allowing them to blend seamlessly into the dark water, while others have completely discarded solid bones, replacing them with gelatinous, water-rich tissues that can easily withstand the crushing weight of the ocean. Their metabolisms move at a crawl. In this frozen desert, patience is not just a virtue, it is a prerequisite for existence. If you had to survive in a world of perpetual darkness and extreme scarcity, how do you think your own instincts would change? Would you find yourself slowing down, matching the slow, cold rhythm of the deep? Or would the constant silence drive you to the edge of sanity? But as you peer closer into this inky wilderness, you realize the darkness is not entirely empty. Occasionally, the black water is shattered by sudden brilliant flashes of cold blue-green light, a planetary phenomenon known as bioluminescence. In the twilight and midnight zones, where sunlight is nothing more than a myth, light has become a living, breathing language. In fact, marine ecologist John Copley estimates that as many as 90% of the animals living between 200 and 1,000 meters deep create light in some form. Unlike the hot, burning fires of the land, this deep-sea light is cold, produced by a highly efficient chemical oxidation reaction inside the animal's own body. It is a trait that has independently evolved nearly 100 times across the history of Earth's oceans. Used to find mates, evade predators, and lure unsuspecting prey directly into the jaws of waiting hunters. The ways in which these organisms use light are as creative as they are terrifying. Consider the lantern shark, which uses glowing patches on its body like tiny biological lightsabers to advertise its unappetizing, venomous spines to potential predators, warning them to stay away. Or look to the walls of deep-sea caves, where the newly discovered golden zoantharian, Corallizoanthus aureus, clings to the dark basaltic rock. When disturbed by a passing creature, this fragile organism flashes a vibrant 515 nanometer green light. Scientists believe this glow acts as a deep-sea burglar alarm, a brilliant flashing distress signal designed to attract the attention of even larger predators to the scene, exposing the intruder and forcing them to flee. In the deep Atlantic, light is not a source of comfort. It is a high-stakes weapon of survival, a flash of brilliance that can mean the difference between life and death in a fraction of a second. Yet, among all these glowing, delicate wonders, there exists a silent, ancient wanderer that outlives almost every other vertebrate on our planet: the Greenland shark. Lurking in the freezing, near black waters of the subpolar North Atlantic, these sluggish giants can grow up to 7 meters long, moving through the deep with a slow, ghostly grace. Their hearts beat at a glacial pace, and their tissues are saturated with natural compounds that prevent their blood from freezing in the sub-zero currents. But their most astonishing trait is their lifespan. Marine scientists, analyzing their eyes, discovered that these sharks can live for over 400 years. Some of the older individuals swimming in the deep Atlantic today were already gliding through the dark. When Galileo first pointed his telescope at the stars, and when the early wooden caravels first crossed the ocean above them. They are living time capsules, silent observers of a centuries-long planetary drama, completely untouched by the frantic passage of human history. This incredible longevity is made possible by their slow, deliberate lifestyle. They move through the cold abyss at less than 1 mile per hour, consuming minimal energy and rarely encountering the human world. For many of these sharks, their eyes are completely clouded over by glowing, parasitic copepods that attach to their corneas, rendering them practically blind. Yet, they do not need sight. In this dark, vast universe of sound and chemistry, they navigate by the cold currents and the scent of decay, proving that even in the absolute absence of light, a creature can find its way across centuries of time. It makes you wonder, what is the true secret to survival? Is it strength, speed, and dominance? Or is it the ability to slow down to adapt and to quietly outlast the storms of the world? When you contemplate a creature like the Greenland shark, swimming silently through the dark for 4 centuries, it forces us to reflect on our own brief, chaotic lives on the surface. Can you imagine what it would be like to experience the world through such vast stretches of time, watching the rise and fall of human empires as mere distant whispers above the waves? Share your thoughts in the comments below. I want to know if the thought of living for 400 years in the quiet dark fills you with awe or a profound sense of isolation. If you find yourself deeply moved by the incredible hidden resilience of life in the deep Atlantic, please hit the like button, share this video with a friend who appreciates the wonders of nature, and make sure you are subscribed to Unseen Nations as we prepare to continue our journey, ascending toward the surface to meet the true masters of the open ocean. We leave the silent, freezing desert of the abyssal plain behind and begin our ascent, rising through the dark, cold layers of the midnight zone, past the dim, ghostly green shadows of the twilight zone, and back up into the sun-drenched, crystal blue waters of the surface. Here, the very nature of survival undergoes a radical change. In the deep abyss, life is defined by stillness, adaptation to famine, and the slow, icy crawl of time. But up here, in the upper 300 meters of the Atlantic, life is defined by a single, relentless word: motion. This is the epipelagic zone, a vast sunlit theater of immense energy, where the ocean's great currents swirl across thousands of kilometers, carrying the lifeblood of our planet from one hemisphere to the other. This entire world-building engine is driven by the sun and the wind, creating a global conveyor belt of water that never stops. Warm, highly saline surface water from the equator, pushed by planetary winds, flows northward in a colossal warm river known as the Gulf Stream. This current moves more water than all the rivers of the Earth combined, transporting vast amounts of heat across the ocean. Where this warm water collides with the cold polar currents of the north, a miraculous transformation takes place. Cold, nutrient-rich waters from the deep are forced upward to the surface in a process called upwelling. These upwellings act like a planetary fertilizer, bringing massive amounts of phosphates and nitrates into the sunlit zone. This ignites colossal blooms of microscopic phytoplankton that stretch for thousands of kilometers across the open ocean. It is a seasonal explosion of life so vast that it can be seen from orbit, a green and turquoise canvas of pure biological energy painted across the deep blue of the Atlantic. And where the food is plentiful, the giants of our planet will inevitably follow. Imagine the sheer scale of this migration. Colossal baleen whales, humpbacks, blue whales, and the critically endangered North Atlantic right whales embark on epic journeys of thousands of kilometers every single year, guided by ancient instinctual maps older than human history. In the winter, they gather in the warm, shallow lagoons of the tropics to give birth and raise their fragile calves in safety. But as the seasons shift and the northern upwellings begin, they turn their massive bodies northward, navigating through the open ocean to reach the cold, nutrient-rich feeding grounds of the North Atlantic. These giants are the true architects of the ocean. As they dive into the dark depths to feed and return to the surface to breathe, they circulate vital nutrients throughout the water column, a process scientists call the whale pump. Even their vocalizations, the deep, haunting songs of the humpback whale, can travel for hundreds of miles through the water, echoing off underwater seamounts and canyon walls like a celestial choir singing in the dark. It is a communication system of profound emotional depth and complexity, a language of low-frequency moans and clicks that we are still trying to decode. Have you ever listened to the song of a whale echoing through the water? It is a sound that feels both alien and deeply familiar, a reminder of a time when the oceans belonged entirely to these gentle giants. How do you think it would feel to drift in the middle of the Atlantic, listening to a conversation that has been repeating for millions of years? But the sunlit waters of the Atlantic are not just a sanctuary for gentle giants. They are also a highly competitive, high-stakes battleground ruled by power, instinct, and dominance. And on this stage, two legendary predators have long fought for the title of the true Lord of the Deep. The first is the great white shark. For millions of years, this ultimate evolutionary masterpiece has patrolled the temperate coasts of the Atlantic, from the rocky shores of New England to the wild, windswept shelves of South Africa. Armed with an array of sensory organs that can detect the tiniest drop of blood from miles away, and jaws lined with rows of razor-sharp, serrated teeth, the great white is built for a single purpose: high-speed, predatory dominance. They are silent, solitary hunters, rising from the dark depths like a shadow to strike their prey with crushing, devastating force. To most of the world, the great white shark represents the absolute pinnacle of ocean terror, an apex predator that has no equal and fears nothing in the cold blue water. But there is another giant that roams these waters, a creature of even greater scale, intelligence, and terrifying cooperative power: the orca, or killer whale. Despite their popular reputation as friendly marine mammals, orcas are not whales at all. They are the largest members of the dolphin family, and they are the undisputed rulers of the global ocean. Operating in highly coordinated family groups called pods, orcas possess a level of social intelligence and tactical planning that is unmatched by any other marine creature. They do not hunt by instinct alone. They learn, they communicate, they pass down ancestral hunting techniques through generations, and they adapt their strategies to target almost any animal in the sea, including the great whales themselves. For centuries, scientists believed that the great white shark and the orca existed in a state of mutual respect, keeping their distance and ruling their respective domains without conflict. But in recent years, off the wild storm-beaten coast of South Africa, where the Atlantic and Indian Oceans collide, a terrifying shift in the planetary balance of power has been caught on camera. It began with a series of mysterious, horrific discoveries. Majestic, adult great white sharks began washing ashore on the sandy beaches of South Africa, their bodies completely intact, except for a single surgical wound. Their livers had been ripped clean out with absolute, chilling precision. The liver of a great white shark is a massive, nutrient-rich organ packed with high-energy squalene oil that provides the ultimate feast for a predator. But who was capable of overpowering and disemboweling the ocean's most feared hunter? The culprits were soon identified. A pair of male orcas named Port and Starboard, easily recognized by their distinctive collapsed dorsal fins. Operating together with terrifying coordination, these two orcas had learned a unique, specialized hunting tactic. They would pursue a great white shark, strike it with immense force to disorient it, and then flip the shark onto its back. This triggers a state of temporary paralysis in sharks known as tonic immobility. Once the great white was helpless, the orcas would tear open its chest cavity between the pectoral fins, squeeze out the oil-rich liver like a tube of toothpaste, and discard the rest of the carcass. The impact of this specialized predation was immediate and historic. The great white sharks, realizing they were no longer the apex predators, fled the region in terror, completely abandoning their prime hunting grounds for months at a time. It was a stark, dramatic demonstration of a fundamental truth. In the deep, there are no equals. There are only those who rule, and those who must adapt to survive. This dramatic shift in the ocean's hierarchy forces us to reconsider everything we thought we knew about the lords of the deep. It is a reminder that even the most feared, ancient rulers of our planet can be brought to their knees by the power of intelligence, cooperation, and adaptation. It makes us wonder about the true nature of power in the wild. Who do you think is the true, undisputed ruler of the ocean? Is it the solitary, evolutionary perfection of the great white shark? Or is it the collective, calculating intelligence of the orcapod? We are descending once again, leaving the sunlit, competitive waters of the surface behind, and plunging back down into the absolute center of the Atlantic basin. We are traveling to a place where the Earth is actively ripping itself apart, where the very foundation of our world is created, and where nature operates on a scale of sheer volcanic violence that is almost impossible to comprehend. Beneath miles of quiet, cold water lies the planet's greatest geological secret, the Mid-Atlantic Ridge. Stretching for more than 16,000 kilometers, this colossal, jagged mountain chain splits the entire Atlantic seafloor in half. Running from the frozen wastes of the Arctic Ocean all the way to the wild, windswept boundaries of the Southern Ocean. It is by far the longest mountain range on our planet, yet its rugged peaks, deep rift valleys, and active volcanic fissures remain almost entirely hidden from human sight, buried under a permanent shroud of pitch-black water. It is a place of continuous division, a planetary seam where the great tectonic plates of our world, the North American, Eurasian, South American, and African plates, are slowly but relentlessly pulling away from each other. In the widening gaps left by this continental divorce, the Earth's crust fractures, allowing molten magma from deep within the mantle to rise and meet the freezing, heavy seawater. It erupts silently under immense hydrostatic pressure, cooling almost instantly to form new volcanic basalt. This is the birth of the planet itself, a quiet, ancient cycle of creation occurring in the dark, miles below the reach of any storm. Can you imagine standing on a ridge where the ground beneath your feet is actively tearing open, where glowing red magma illuminates the black abyss, and where new land is constantly rising from the deep? It is a landscape of profound, unsettling beauty, a place where the internal energy of the Earth and the cold weight of the ocean exist in a state of eternal, dynamic tension. But for centuries, science believed this massive hidden mountain range was a desolate, frozen desert of basalt, completely devoid of life. It was not until 1985 that oceanographers using advanced deep-sea submersibles made a discovery that changed our understanding of biology forever. They found that the Mid-Atlantic Ridge was not dead. It was alive, home to some of the most extreme alien environments ever recorded on Earth. Deep within these volcanic rifts lie active hydrothermal vent fields, massive mineral-rich chimneys known as black smokers. These structures are formed when freezing seawater seeps deep into the fractured ocean crust, where it is superheated by underlying chambers of magma to temperatures exceeding 400 degrees Celsius, hot enough to melt solid lead. As this highly pressurized, mineral-saturated fluid is expelled back into the near-freezing ocean, the dissolved minerals instantly precipitate, building towering chimneys that can reach over 30 meters in height, spewing dark, toxic plumes of metallic sulfides into the water. Consider the spectacular, newly discovered Moitira vent field, situated nearly 3,000 meters below the surface. Named after a legendary battlefield of Irish mythology, Moytira sits at the base of a sheer 200-meter cliff that is coated in thick, ghostly sheets of bacterial slime. To navigate this area is to experience a world that feels entirely unnatural. From its towering chimneys, roaring plumes of superheated fluid rise like smoke from an underwater industrial complex, creating a chaotic soundscape of deep volcanic rumbles and mineral-laden surges. Yet, in an environment that should be completely sterile, where the water is highly toxic, acidic, and under crushing pressure, entire ecosystems thrive in complete independence from the sun. These vents support unique communities of life that have bypassed the traditional rules of solar-powered evolution. At the Lucky Strike vent field, located at a depth of over 1,600 meters along the ridge, scientists discovered a microscopic marvel, the dragon nematode, officially named Dracograllus miguelitus. This tiny specialized worm possesses the extraordinary ability to grip the hard basaltic surfaces of inactive volcanic chimneys, actively moving across the mineral walls to graze on dense mats of sulfur-oxidizing bacteria. Alongside them are swarms of pale, blind vent shrimp that crowd around the scalding mineral columns. Although they have lost their traditional eyes in the permanent dark, they have developed a unique, specialized photoreceptor on their backs that is tuned to detect the faint, near-infrared glow emitted by the superheated vents. They navigate not by sight, but by thermal energy, living their entire lives in a warm chemical bubble surrounded by a cold, indifferent abyss. It is life thriving on pure chemistry, a testament to the incredible, unyielding resilience of nature. When we contemplate these hydrothermal ecosystems surviving on the toxic, volcanic breath of our planet, it forces us to ask a profound and unsettling question. Did the first sparks of life on Earth truly begin in warm, sunlit tidal pools on the surface? Or did they ignite in the crushing, mineral-rich darkness of these deep-sea volcanoes? If life can thrive in the extreme toxic rifts of the mid-Atlantic ridge, it suggests that the potential for life in our universe is far greater than we ever imagined, existing in the dark, icy oceans of distant moons where the sun never shines. Most of humanity lives with its eyes fixed on the night sky, spending billions of dollars to search for signs of life on distant, dusty planets, completely unaware that we have a wild, unmapped alien world right here on Earth. We have mapped the surface of the Moon and the deserts of Mars with greater precision than we have mapped the floor of our own oceans, leaving an area twice the size of Mars entirely unexplored. But you are different. You are here with us, descending into the ultimate quiet, seeking to understand the deep, forgotten depths of our home. If you believe we should prioritize exploring and preserving our own oceans before searching for life among the stars, Drop a comment below and share your thoughts. What do you think is the most fascinating secret still waiting to be discovered on our planet? If this journey into the Atlantic has captured your imagination, please hit the like button, share this video with those who love the mysteries of science, and ensure you are subscribed to Unseen Nations. Deep in the vast, windswept reaches of the South Atlantic, there is a boundary where the rules of our planet do not just bend, they fracture entirely. This is not a hazard of crushing water or violent waves. It is an invisible cosmic danger that reaches down from the heavens to touch the sea, a silent tear in the very magnetic armor that protects all life on Earth. Scientists call it the South Atlantic Anomaly, but to the astronauts, pilots, and satellite engineers who cross it, it is known as the Bermuda Triangle of space. Imagine flying hundreds of miles above this gray, surging ocean, cocooned in the state-of-the-art metal hull of the International Space Station or a multi-million-dollar satellite. Everything seems routine. The instruments hum quietly. But the moment you pass over the coordinates of the South Atlantic, the universe begins to behave abnormally. Computer screens glitch. Solenoids trigger without warning. Sensitive electronic arrays, designed to map the deep cosmos, suddenly suffer temporary blindness as they are bombarded by a sudden, intense barrage of highly charged proton radiation. This is the region where Earth's inner Van Allen radiation belt, a massive ring of trapped solar particles, dips down to its lowest altitude, hanging just 200 kilometers above the ocean's surface. In any other part of the globe, this radioactive shield is held high in the heavens, thousands of miles above our heads. But over the South Atlantic, our planet's magnetic field is anomalously weak, sags like a worn-out net. This allows cosmic rays and supercharged solar wind to pierce deep into our upper atmosphere, creating a hazardous zone that threatens our most advanced technologies. The Japanese Space Observatory, Hitomi, a spacecraft designed to unlock the secrets of black holes, was destroyed after passing through this anomaly. Its direction-finding systems were temporarily blinded by the radiation, causing its gyroscopes to malfunction and spin the satellite out of control until its solar panels tore away, leaving it a dead piece of cosmic drift. But the most unsettling aspect of this cosmic tear is how it affects the human body. Astronauts sleeping in their quarters on the space station report a bizarre, ghostly phenomenon. Even with their eyes tightly closed, in the absolute quiet of orbit, they see bright, silent flashes of light slicing through the darkness of their closed eyelids. Mysterious, fleeting shooting stars known as phosphenes. These are not optical illusions. They are highly energetic cosmic rays passing directly through the physical structure of the astronaut's eyeballs. striking their retinas and igniting tiny, silent sparks of light inside their minds. It is a haunting, physical contact with the raw power of the universe, a silent reminder that above the South Atlantic, we are completely exposed. And yet, the ultimate mystery of this cosmic weakness lies not in the heavens, but deep beneath the ocean floor. Geophysicists have discovered that this massive dent in our magnetic field is actually driven by a colossal structure buried thousands of miles below the crust, at the boundary where our mantle meets the molten iron of the Earth's core. Located directly beneath Africa and the South Atlantic is the African Large Low Shear Velocity Province, a gargantuan reservoir of superdense, ancient rock the size of an entire continent. This massive mantle plume disrupts the natural churning flow of molten iron in the outer core, acting like a giant dampener that weakens the magnetic field directly above it. It is a chilling connection, a deep primordial geology locked in the silent interior of our planet, whispering through miles of solid rock to tear a hole in our shield against the stars. Have you ever considered that the forces shaping our future in space are actually governed by secrets buried deep within the dark, unreachable heart of the Earth? As we move our focus northward, we find that the Atlantic is hiding another silent, unfolding crisis, one that threatens to fundamentally rewrite the climate of the entire Northern Hemisphere. South of Greenland, in the cold, misty waters of the subpolar North Atlantic, sits a massive patch of ocean that defies the global warming trends seen across the rest of our planet. Oceanographers call it the cold blob. While global ocean temperatures rise to historic heights, this specific localized patch of water is getting steadily, inexplicably colder. It is a physical footprint of a system in distress, a warning sign that the great thermal engine of the Atlantic is losing its strength. This cooling is intimately linked to the weakening of the Atlantic meridional overturning circulation, the AMOC. This colossal system of currents acts as a planetary conveyor belt, carrying warm, salty tropical water from the Gulf of Mexico northeast across the Atlantic, warming the coastlines of North America and Western Europe by up to 10 degrees Celsius. As this warm water reaches the freezing subpolar regions, it releases its heat into the atmosphere, cools down, and becomes incredibly dense and heavy, sinking deep into the abyss to flow back south and complete the loop. But today, that loop is beginning to falter. The rapid melting of Greenland's massive ice sheets is dumping colossal volumes of fresh, buoyant water into the North Atlantic, diluting its salinity and preventing the water from becoming dense enough to sink. If this downwelling fails, the entire conveyor belt could collapse. A collapse of this current system would trigger a catastrophic irreversible shift in global weather. Europe would be plunged into a localized ice age, with winter temperatures dropping precipitously, while sea levels along the eastern coast of the United States would surge rapidly, drowning coastal cities under feet of rising water. If you woke up tomorrow to find your city buried under feet of ice, or your coastline permanently swallowed by a rising tide, how would you adapt? Would you flee, or would you try to build a life in a world completely rewritten by the cold? Share your thoughts in the comments below.